All right, so I wanted to walk you through the problems on the last page of the guided notes, just in case you felt a little hurried or in case we didn't get to them, so you could watch this video at your leisure and fill them in. So again, we're solving by factoring, so the process is to make sure your equation equals 0, factor the quadratic, set each of the factors equal to 0, solve for x. So first problem, already equals 0, so we're going to factor, looking for two numbers that multiply to give you -6, add to give you -5. And those numbers happen to be -6 and +1. Now I could go through and do the grouping or box method with that, but anytime my coefficient on x squared is 1, like it is here, the two numbers that I got, the -6 and the +1, are going to end up in the parentheses. So x minus 6, x plus 1. But if you wanted to go ahead and do the box or grouping method, you're certainly welcome to do so. So now I'm going to set each of my factors equal to 0, because I have a product that equals 0. And then solve each of the little equations. So those are the two answers to this problem. Second problem, doesn't equal 0, so I need to move everything to the same side so that it does. I'm going to factor, so I'm looking for two numbers that multiply to give you -12, and add to give me -1. Those numbers are -4 and +3. I'm going to factor using the box, because that's what I prefer. 2x squared goes in the upper left, -6 goes in the bottom right. The middle term, the -x, gets broken up using these two numbers, so -4x and 3x. I'm going to look at the first column and pull out the greatest common factor. Notice the numbers only have a common factor of 1, but I can pull out an x. And then I'm going to go around the box. So let's see, this is x, this is 2x squared, so this would have to be 2x. This is 2x, this is -4x, so this would have to be -2. This is -2, this is -6, so this would have to be 3, and then I can check that 3 and x give me 3x. So my factors are 2x plus 3 and x minus 2, and those equal 0. So each factor equals 0, and I can solve for x. And again, if you did it by grouping, that's fine too. Now, for this problem, I have a common factor in there are two terms. So instead of jumping in right away into the box, I'm going to pull the common factor out. I have a common factor in the numbers, which is 3, and I have a common factor in the variables, which is x. And when I undistribute that, that will give me an x minus 4. And then people try to make this more complicated. This process is going to follow exactly what we did in the previous problems. I'm going to set each of the factors equal to 0, and I'm going to solve. So 3x would equal 0, and x minus 4 would equal 0. So when I solve for x in the first equation, I divide both sides by 3, and 0 divided by 3 is 0. And in this equation, I would add 4 to both sides, and x would equal 4. The fourth problem already equals 0, so I'm going to factor. Notice that's a difference of 2 squares. So I'm going to jump right into the pattern, and then set each of the factors equal to 0, and solve for x. Now, problem at the bottom left has a typo in it, so I'm going to fix that. Instead of -72x, that should be -36x. So notice it doesn't equal 0, so I'm going to add 36x to both sides. Now when I do that, I want to write this in the right order, where the squared term is first, and then the x term is next, and then the constant term is last. So this equals 0, so I can go factoring, but please, again, look to see if there's a greatest common factor, because there is here. It happens to be 6. So I'm going to pull that out. Then the quadratic that's here, two numbers that multiply to give me 9, that add to give me 6, 3 and 3, and the coefficient of the x squared is 1, so I can jump right into the factors. And now I can use the zero product property. So 6 can equal 0, or x plus 3 can equal 0, or x plus 3 can equal 0. Now, I want you to notice the 6 equals 0. 6 never equals 0. There's not even a variable in there, right? It's saying that two numbers that aren't equal are equal to each other. That's just not true. It's not going to give you any solutions at all because it can never be true. However, the other two equations can. Now, if you wrote x equals -3 and you only wrote it once, that's perfectly fine. And then on the last problem, I also am going to start by pulling out a greatest common factor. This time it happens to be x. I'm going to take the quadratic and I'm going to factor it. Two numbers that multiply to give me -48 and add to give me -13. Those two numbers happen to be -16 and +3. This time I'll do the box method. I just like the box method way better. So 6x squared, -8 goes here. The -16 and the 3 break up the middle term. And then I look at my first column and say greatest common factor. The greatest common factor between 6 and 3 is 3. And then between x squared and x is x. So if this is 3x, this is 6x squared, this needs to be a 2x. If this is a 2x and this is -16x, this has to be a -8. If this is a -8 and this is a -8, this has to be a +1, and I can check +1 and 3x give me 3x. So my factors from that quadratic were 3x minus 8, 2x plus 1, and then remember that I actually had this x that was up here that needs to come down as well. Now, the factors are multiplied together, they give you 0, so you can set each of them equal to 0. X equals 0? Hey, that's fine. X actually equals 0. Now notice this is different than what we had over here because this said 6 equals 0. That can never happen. But x can totally be 0. In fact, if you plugged 0 in for all the x's here, you would see it would make the equation work. Then I solve the other two equations as I've done before. Oops. I'm trying to save some space here because I'm at the bottom of my page. Now notice we got 3 answers on this one, and the power that I started with, the highest power was a 3, and all of the others had powers of 2, and we got 2 answers. There's definitely a connection there. We'll talk more about that later in the year.